Hi, my name is Ravi Kumar T, Assistant Professor, Department of Mechanical Engineering, SVIT, Bangalore. So today I am here to explain in EME, Elements of Mechanical Engineering is common to all the branches, first year engineering course. So module 3, in the module 3 I am explaining the unit 2. Okay, so unit 2, refrigeration and air conditioning. So what is a refrigeration? So what is a refrigerator, refrigeration, refrigerants? These are the three different words you have to be remember. Okay, so refrigerator is a device. Okay, is a device used to maintain low temperature. Okay, well below the atmospheric temperature within a required space. Okay, so that is a refrigerator. This is commonly you call it as a fridge. Okay, so fridge in the fridge it will maintain a low temperature which is below the atmospheric temperature, but whatever the things you have to be required to cool. Okay, so within a required space it is maintain a temperature. What is refrigeration? Refrigeration is what? So very simple thing. So method is reducing the temperature. Okay, so method of reducing the temperature between well below the surrounding temperature. Okay, so it's reducing, and also it has to maintain the same temperature. Okay, so that is a refrigeration system. What is a refrigerant? So refrigerant is a heat carrying capacity. Okay, so in the evaporator it's the refrigerant, it absorbs the heat. Okay, absorbs the heat from the space, and it absorbs heat from this space in the evaporator, and it rejects to outside in the condenser. That is the function of the refrigerant. Okay, we'll see how does it work. So this is completely working on based on thermodynamic cycles. Okay, so you know the second law of thermodynamics. So second law of thermodynamics says that it is impossible to move from low temperature region to a high temperature region without any external work is supplied. But this refrigeration system is working on the same thing. So it is moving from, temperature is moving from low temperature region to high temperature region with external work is supplied. Okay, so that is the basic principle of refrigeration system. See, always the refrigeration COP, conventional refrigeration COP should be more than 1. Okay, so what it will absorb the heat where you have to cool, and then it is rejected to atmosphere. Okay, but to absorb the heat you will supply some work. Okay, so that is the second refrigeration principle. Okay, so where are the applications? So these are the many applications: ice making plant, industrial air conditioning. Okay, almost everywhere you have seen these are the same different applications of refrigeration system. Okay, so before entering into things, you have to study some basic definitions. So basic definitions like the refrigerator, refrigeration, and refrigerant. Okay, similarly you have a different thing. One is a refrigerating effect. Refrigerating effect is very simple. The amount of heat is absorbed, okay, now from the refrigerating cycle by the refrigerant in refrigerating process. Okay, this is the refrigerating effect. Very simple. Amount of heat is absorbed from the refrigerating cycle by refrigerant in refrigerating process. Very simple. Okay, so next, ice making capacity is the ability of the refrigerator to convert water into ice at room temperature. Okay, water into a ice at room temperature. So what is a 1 ton of refrigeration is very important definition this is. So 1 ton of definition is 1 ton of refrigeration. It defines the capacity of refrigeration system. Okay, so the rate of refrigeration system will be termed in terms of ton of refrigeration. What is this? So 1 ton of refrigeration is a capacity of refrigeration system which is used to extract heat from 1 ton of water at 0 degrees Celsius and convert it into a 1 ton of ice in 24 hours. Very simple. See, amount of heat is extract from 1 ton of water at 0 degrees Celsius and convert it into a 1 ton of ice in 24 hours. That's it. Okay, very simple. So 1 ton of refrigeration you will get 210 kilojoule per minute, or you will get 3.5 kilowatt. So what is the next? So next is a performance of coefficient of performance. See, you take any refrigeration system or air conditioning will termed the performance, or will term the performance of refrigeration system in terms of COP. Okay, what is the COP? So very simple thing, the amount of heat is absorbed by refrigerant while passing through a evaporator, okay, to work input, okay, or work is supplied. It is very simple, amount of heat absorbed to work supplied, that is a COP, amount of heat absorbed to work supplied. Okay, COP is always greater than 1 for conventional system. Okay, relative COP. Relative COP is a very simple. It is a ratio of theoretical COP to a actual COP. That is, okay, sorry, actual measured COP to a theoretical measured COP. I'm sorry. So that is a relative COP. Okay, we see what are the refrigerant and what are the properties of refrigerant. See, refrigerant, you already know the refrigerant in the evaporator it is absorbed, but in the condenser it is rejected to atmosphere. Means amount of heat is absorbed by evaporating at low temperature and gives up heat by condensing at high temperature. That is a refrigerant. What is the property? So you will be having a thermodynamic property, physical, chemical and other property. So thermodynamic property, low boiling point. So why you require a low boiling point? See, if the any refrigerant is having a high boiling point, so it catches a fire. So that's why we require a low boiling point and low freezing point. So if the refrigerant is moving in a evaporator, so if the freezing point is very high, so there is a chances of freezing in the evaporator. So that's why we require a low freezing point. And good refrigerant should have a high critical temperature and should have a high latent heat of evaporation. Okay, so why latent heat of evaporation is more? Because in evaporator it should be changes a phase from liquid to a vapor, but in condenser it changes from vapor to a liquid. So that's why if we want to convert this one form to other form, we require high latent heat of vaporization. Okay, so what are the physical property? So physical property, yeah, you require a low specific heat because you require to cool at low temperature. Okay, that's why low specific speed, low specific volume. If the specific volume is very less, you require less capacity of the compressor. Okay, if the specific volume is more, you require high capacity of the compressor and should have a high thermal conductivity, should have a low viscosity, high critical insulation and non-toxic, non-flammable, non-corrosive. These are the different properties of refrigerants. Okay, and then commonly used refrigerant. There are 6 commonly used refrigerants: air and water, ammonia, sulfur dioxide, carbon dioxide, methyl chloride, furan 12 and 22. Okay, so these are the commonly used refrigerants. So for air and water is the first refrigerant. So which is air is used in aircraft industry and water is used as an adsorbent in vapor absorption refrigeration system. Ammonia is commonly used in ice plants. Okay, because ammonia, if you use ammonia, you get COP is more. Okay, and ice making capacity is more. So that's why you're going to use in cold storage and ice making plants. Sulfur dioxide. So majorly you're going to use a household refrigerant in olden days, but nowadays it's exhausted. So now because due to some property like flammable and so that's why the sulfur dioxide is not used in a household refrigerant nowadays. Carbon dioxide. See, carbon dioxide, you can see where the emission is more, there the temperature is very less. Okay, because of carbon dioxide. So that's why this carbon dioxide is used in marine refrigerator system. And methyl chloride. So methyl chloride usually they'll prefer only for domestic refrigeration system and industrial refrigerator system. Furan 12 and 22. So furan 12 is a one group. So in the furan 12 you will be having different variety of refrigerant. So this is commonly used for HFCs and CFCs. Okay, furan 22 is used for only air conditioning system. So nowadays they are using R134A and R290 is a natural refrigerant. Okay, in Godrej system, Godrej Refrig, you're going to use a R290. Okay, what are the different types of refrigeration systems are there? But many types, but for your syllabus only 2 are there. What are those 2? One is a vapor absorption and vapor compression refrigeration system. Okay, so what is a vapor absorption refrigeration system and what is a vapor compression refrigeration system? Okay, first we'll see compression, and before that, yeah, we have to see the parts of refrigeration system. What are the parts? Evaporator, compressor, condenser, expansion valve. What happen in evaporator? See, what evaporator, heat is absorbed with the help of refrigerant and convert phase from liquid to vapor. Okay, that is the function of evaporator. Okay, at constant pressure, this will be taking place at constant pressure. Okay, the input of evaporator is very less pressure. Okay, less pressure and less temperature, but output of evaporator will be the temperature, little temperature is increases and the pressure remains same. Compressor is used to compress the refrigerant to high pressure and high temperature. Okay, so next, condenser is used to reject the heat okay, with the help of refrigerant. Okay, now, so in the condenser you're going to use, there is a phase change from a vapor to a liquid. Okay, so it will taking place at the constant pressure. Again, in the condenser you can observe pressure remain constant but the temperature is reduces. Okay, expansion wall is used to reduce the pressure. Okay, the temperature and it also reduces the temperature of the liquid refrigerant before it passes to a evaporator. Okay, yeah, we shall see the vapor compression refrigeration system. You can observe the blue line indicates the less temperature and red line indicates high temperature. Okay, you can first will start from the compressor. In the compressor the refrigerant will fill. Okay, so compressor refrigeration gas is compressed to high pressure and high temperature. So the high pressure and high temperature gas will be sent to a condenser. So where it changes a phase from vapor to a liquid. Okay, while changing the phase you can observe, so only pressure remain constant but there is a variation in temperature, but the complete temperature will not reduce in the condenser, only little temperature will reduce. Okay, so in the condenser there will be a fan is used. So with the help of fan, the ambient atmospheric air will be flow over the condenser, so that little temperature is reduces and pressure remain constant. So that will be flow through a metering device or expansion wall. So where the pressure is completely expands to a low pressure and even temperature is also reduces. So low temperature and low pressure liquid refrigerant will flow to a evaporator. So where heat is absorbed with the help of refrigerant and changes a phase from liquid to a vapor at constant pressure. Okay, and there will be a little increase in temperature, the pressure remain constant. Okay, so the low pressure and low temperature liquid vapor refrigerant will be flow to a condenser, so that the cycle will be repeated. Okay, so here you can use the R134A as a refrigerant or F12 as a refrigerant in the vapor compression refrigeration system. What about vapor absorption? See, vapor absorption, the refrigerant is absorbent and refrigerant. Absorbent is used as a water and refrigerant is ammonia, or it may be a lithium bromide. Okay, very simple thing. So in the absorber, the ammonia and water will mix together and form a strong solution. Okay, so that strong solution will be pumped to a generator through the heat exchanger. Okay, so what happen in the heat generator? So in the generator, the mixture will start heating at the external source, so that there is a separation of vapor and as well as liquid. Okay, so the liquid is again back to a absorber. Okay, through the heat exchanger and through the pressure reducing valve. See, when the liquid or weak solution will be sending back to a absorber. Okay, so there is a heat exchange between strong solution and a weak solution in the heat exchanger, so that the weak solution temperature is little bit reduces and then again it's passing through a pressure reducing valve. So where the pressure is completely reduced and temperature is also reduced, so that the weak solution will be sent back to a absorber, and whatever the gas is generated in the generator, so high temperature and high pressure gas, that will be flow to a condenser, where air will be passed over a condenser, so it is rejected to a atmosphere and changes a phase from vapor to liquid. So while changing a phase from vapor to liquid, this will be taking place at constant pressure. Okay, so and then pressure remains constant and then temperature is reduces. So that will be flow to a expansion valve where the pressure is completely reduced and temperature is also reduced. That will be flow to a evaporator. Okay, so what happened? The evaporator input is liquid refrigerant at low temperature and low pressure. So that will be flow to a evaporator. So what happened in the evaporator? It changes a phase from liquid to a vapor. Okay, so by heat is absorbed with the help of refrigerant and changes phase. So again the absorber input is what? Is a air vapor. Okay, so low pressure, low temperature vapor will be sent to a absorber. Okay, this is about your vapor absorption refrigeration system. So what is the difference between? So working method is very simple. It is refrigerant vapor is absorbed and then heated, but here vapor is compressed. Here you are going to use the mechanical energy and there we are going to use the heat energy. Okay, the maintenance is VBR is very less and VCR is more. Operation quite simple operation because you're not using any compressor, but there is a difficulty operation because you're using a compressor. COP is very low in the vapor absorption compared to VCR, but VCR it's very high. Okay, it reduces a part load. Okay, part load it VCR COP is reduces. And refrigerant you're going to use ammonia and F12. Cost is low and high. Okay, size compact and bulky. Leakage no problem, and there is a chances of leakage in the vapor compression. Okay, so air conditioning. Air conditioning is what? You have to maintain a temperature and also you have to filter the air. So that is the air conditioning. Okay, so you have to maintain temperature and as well as humidity. Humidity is what? Moisture present in the air. Okay, that you have to control. Okay, and you have to purify the air. Okay, you have to clean and you have to filter in the air. So that is the air conditioning. You will be having two, comfort and industrial. So comfort and the principle of air conditioning is similar to your refrigeration system. Okay, so very simple. From the room the air is drawn, okay, and it is filtered and again it cools down. The same air will be supplied back to your room. Okay, so in air conditioning at any cost you will not get atmospheric air to a room. Okay, you will get only the whatever the air is circulating in the room, that will be filtered and that will be cooled, again it will be sent back to a room only. So that is the principle of refrigeration air conditioning. Okay, so you will be having a room air conditioning. Yeah, you can observe. So the same components will be used. So condenser, you can observe evaporator fan, condenser fan. You will be having a compressor. And is very important thing, one setup is will be placed in inside the room and the other will be placed in outside the room. So the condenser part will be outside the room and evaporator part will be inside the room. So what happened? When the evaporator fan starts, the air will be sucked to a evaporator through the filter. So where it is filtered and clean, the cleaning air will be supplied over the evaporator. So what happened? The evaporator it absorbs the heat, okay, and changes a phase from refrigerant vapor to a refrigerant liquid to a refrigerant vapor. Okay, so that refrigerant vapor will be supplied through a capillary tube and then will be sent back to a condenser. Okay, what happened in the condenser? Condenser fan will operate, so it sucks the air from the atmosphere, so that air will be flowing over the condenser coil. So what happened? The heat will be carried away carried to a atmosphere. Okay, so there is a changes from vapor to a liquid. Okay, so in the condenser, vapor to a liquid, so the pressure remain constant, then temperature will be reduces. Okay, so that air will be supplied back to a room temperature. So finally you will get in the room you will get low temperature, low pressure, in the maintained temperature, and filtered air will be supplied back to a room. Okay, so it's very important thing. So this is the working principle of room air conditioning. Okay, so what is the difference between? So very simple. So refrigerator only reduce the temperature and maintain, but air conditioning will also filter the air and it also maintain the humidity. Okay, so refrigerator is always a cool temperature, but you can use it in some air conditioning, you can use it in summer and as well as winter condition. So and unit will be completely located in inside the room, and the air conditioning, the part of the evaporator will be inside the room and a condenser will be outside the room. Condenser and compressor will be outside the room. So in the refrigerator you are not required any fan or blower, but air conditioning you required. So refrigerator capacity is very high and air is very low, and more weight and less weight. Okay, so mainly used in permissibles, but air is in a congenial atmosphere for human comfort. Okay, so this is about your refrigerator and air conditioning. So EME module 3 part unit 2. Okay,